here is my name, Alexandra Drouet. Date is 10/20/22. I apologize, I'm a little bit sick, so if I sound kind of bad, sorry. So I'm going to do my case connection study now. So I decided to do case connection 2 and 4. So let me make sure I can get the questions up really quick. Hold on. There we go. Okay. So the second question, question number 2 was about a 16-year-old female that was recently diagnosed with muscle glycogen phosphorylase disease. And they're asking questions with the clinician about how to navigate this new diagnosis, basically. So I'll read the question and then I'll say how I would respond. So question number 1, she says, I'm not sure I understand the issue. Can you explain how muscle glycogen is used normally during exercise? So I would respond with, sure, I can help you understand this a little bit better. So during exercise, skeletal muscles are able to break down glycogen to help meet energy demands. And that's basically the gist of the pathway, but we call this process muscle glycogenolysis. So this occurs through a cycle that starts by stimulation of certain hormones, and this one it's epinephrine to be exact. The epinephrine tells the muscle cells to combine with an energy molecule called ATP with adenyl cyclase, and that'll make cyclic AMP, what we call CAMP. And CAMP is like this big important molecule. It reacts with a phosphodiesterase to produce adenosine monophosphate, which is specific to muscle skeletal cells. It does not have anything to do with the liver. It's just in your skeletal cells. And so at the same time, it's reacting with another enzyme called protein kinase A, and this in turn works with phosphorylase kinase A. Excuse me. Ooh, sorry. This is all a really fancy way of just saying that it's the process that's used to break down large stored sugar molecules for use when there's no glucose readily available that has been consumed by the diet within the very recent present. So question number 2, I really like to take long walks. Will I still be able to do this with my friends? So I would say to this, yes, you can definitely still participate in moderate aerobic activities. Research actually shows that not participating in any physical activity or reducing your physical activity might worsen this disease and have a lot more prominent symptoms. This is due to an increase in the enzyme that we test in the blood called creatine kinase, or CK. In your disease, you probably have more elevated levels than we'd see within a normal range, which is going to be your new normal, but essentially we want to try to keep those levels as low as possible still. So having moderate exercise will actually help keep those levels a little bit lower than the alternative. But it's really important to listen to your body when you start to become fatigued after certain times of walking. Make sure to take breaks. But it would be prudent to continue an exercise regimen. So question 3, as a result of this deficiency, will I need to get up at night to eat to maintain my blood glucose levels? So no, you will not need to consume any extra foods during periods of rest, especially as the deficiency does not really affect liver. It only affects skeletal muscles that work during exercise and activity. There is moderate clinical support that suggests eating a carbohydrate-rich snack or some juice before a workout may improve the initial symptoms, as that there is some free glucose for the muscle cells to be able to utilize. And it is supported that more carb-heavy versus protein-heavy diet is probably better for this patient population. So just keep that in mind as well. Question 4, do I need to worry about producing excessive lactate during intense anaerobic exercise? Sorry. So I would say There's no need to worry about excessive lactate during exercise, actually. This is because the pathway that I described earlier is blocked in certain stages, causing the buildup of the glycogen in your muscle cells and thus the deficiency and the disease process. So the glycogenolytic pathway is insufficient to produce the necessary metabolic demands, so a chemical called pyruvate doesn't get produced or synthesized, really. So if pyruvate is not present, then lactate can't move forward because you need pyruvate to make lactate, if that makes sense. So that's the half of the case connection. Let me do the other half. Okay. I chose question number 4. Well, yeah, 4 right here. It's about a previously healthy 2-month-old with jittery spells several hours after breastfeeding. Baby only had breast milk since birth. Baby sleeps quite a bit more after being fed, which is recent according to the mother. Hypoglycemia is the only pertinent lab. And then they did the epinephrine test where they gave epinephrine, and there's no increase in the blood glucose, but there is an increase in lactate. And then upon objective assessment, there's an enlarged liver, and then they also see that blood glucose is normal after breastfeeding, but not during the fasting glucose. So this is based on information about what is glycogen diagnosis. So I chose answer C, glycogen storage disease, so the inability to utilize glycogen, essentially. So the symptoms described by the mother and the objective data kind of helps us guide this conclusion that the baby has a deficiency in the ability to store this glycogen. So unable to derive the glucose from glucose 6-phosphate via stored glycogen or gluconeogenesis. So therefore, she must really depend on dietary intake to not have hypoglycemia. So she's only euglycemic after being fed, was what we got in the question. So this explains why the baby becomes hypoglycemic after fasting, because there's no stores to be utilized after the initial glucose is taken up. This also aligns with the patient having the enlarged liver and not having any reaction with the epinephrine injection. This is because glycogen is building up within the liver of the baby. And we further confirm this by the increase in lactate production. The lactate will build up as the alternative pathway with the anaerobic synthesis, since there is no aerobic pathway to be able to be followed with glycogenolysis. So I also want to talk about why the other answers aren't correct. Let me see. The first one is hereditary fructose intolerance. So it can't be hereditary fructose intolerance because, as the mom said, the baby's only been introduced to breast milk, so there is no fructose being introduced to the baby that would cause this kind of disease, and nothing has really changed in the diet in the last couple months that would show this anyway. So the other one is galactosemia. Galactosemia, it can't be an answer due to the exclusivity of the breast milk combined with the length of the time that the baby has been nursing. So we would see galactosemia in the first few days of birth, really, the first few days of feeding in infancy, due to the accumulation of the galactose 1-phosphate in the liver. So like I said, the length of time the baby's been breastfeeding would really lead us away from that as a diagnosis. So one of the big reasons for that is that the glucose 6-phosphate dehydrogenase deficiency isn't affected by the diet. I skipped it. Sorry. The last answer was glucose 6-phosphate dehydrogenase deficiency. Sorry, I was moving fast. So the reason that one's not right is that it's not really due to diet. It's a hemolytic disorder with the red blood cells, and you would see this right after birth as well. You'd see it in the form of jaundice, and same with galactosemia. It happens right off the bat, and it's not really, this one's not really due to dietary issues. So that really wouldn't come across the radar for these type of symptoms for the subjective and objective data. Yeah, and then I will turn in my works cited with this, as well as some of the script. So thank you so much.